And there is no error correction here. You can connect things in any ways. You can even, fry the board and all of that. So this is not something that a complete novice can understand. You need to be a bit initiated into this whole thing. And if you compare this with the Lego connectors, this is sometimes I try to imagine if you would, we go into the future and then we find in a archaeological site some of this microcontrollers board, and just looking at the connectors, we can tell who designed them. So this is, quite different from this, and this is a difference that we should pay attention to. And I'll go back to that in a little bit. So here you see, like, there is ground and this little, curly little characters and digital and all these things that kids really don't know what they are, and they probably should not be exposed to that before the right time. So this is the wiring model, which is a microcontroller with very basic circuitry around, and then all the other stuff you have to add as external components, including power, including all the resistors and all of that. And that's why it becomes like this, because you have to add all these components. But this is not really a problem, because this was being designed for people who wanted all this flexibility, as we're going to see later. So this is the basic, from the basic stamp web page, and you can see here that say, oh, this was the tool the need to do a hobby, and this was the user base was scientists, hobbyists, engineers, and all of that. So the basic stamp was designed for that. And this is from Hernando Bargan's thesis in the Vera Institute in Italy, the thesis that created wiring and then created Arduino. And he said the programmable bricks, Cricket, Logan, Gogo board, they are very limited systems for activities involved in physical computing. They lack the flexibility required for general purpose applications. So they were not really designing for kids, and I think that's an important thing that we should keep in mind. They were designing for interaction designers. So there are two very different traditions that ended up in very different designs, and this is a quick summary of the differences. So one used professional software like C, Java syntax. The other used logo derivatives. One, used professional hardware, all these breadboards and resistors and things like that, and the other one used design hardware, so these polarity-free connections, built-in batteries, motor drivers that can control motors. And there's also an issue of, the hacker's mindset, which is, oh, you should figure things out by yourself, looking online, because there are so many tutorials online. But we know that lots of kids don't do that. They don't even know where to start. So the design is not in the device, is assumed that the user will figure things out. And on the other side, the Cricket model, we have a mindset that we should include people. The materials should be inviting. The material should not be an obstacle. And the materials should be pluralist. So there should be epistemological